Do you ever wonder how scientists came up with the structure of an atom?
Why do you want to know?
I don't know. I mean, an atom is so small, how do they even know what they're looking at?
Well, I bet there'll be a lot of disagreements. It'll be like a wars.
Really? I don't know, but I mean, if you could find out how it actually works, then you'd be a star, like right there.
Well, do you know any experiments that contribute to the modern design of atomic structure?
I don't know. What about this J.J. Thomson guy?
Nah, I don't trust people who go by their initials.
Really? Okay. What? What about Rutherford?
Rutherford seems trustworthy. Let's see.
In case you didn't get what just happened, here's a crash course on what did.
Oh, great. So, what was wrong with Thomson's model?
Before 1911, J.J. Thomson's plum pudding model was the accepted atomic structure.
Pudding? I love pudding. Where is it?
No. Not that plum pudding. This plum pudding, created by J.J. Thomson in 1904.
Can you eat it?
No, but it was a big step forward for atomic structure. Anyways, fast forward to 1911, Thomson's friend Rutherford decided that he wanted to prove Thomson's model correct once and for all, and decided to use his expertise in radiation to do so. He created the gold foil experiment with an alpha particle source, uranium, and aimed it at the gold foil along with a detector behind it.
So, what was gonna happen?
Rutherford expected the alpha particles to pass straight through the thin gold foil and only hit the back of the detector. However, when he saw the results, the detector had detected alpha particles all around it, not just the back.
How? That wasn't expected.
Thomson's model showcased a model with only electrons with little to no mass in the atom at all. If this were the case, the alpha particles would have passed straight through it.
So, in that case, the nucleus would be the best explanation, right?
Exactly. Rutherford hypothesized that there was a center of the atom, a center of mass large enough to deflect the oncoming alpha particles. Rutherford quickly brought these findings to light with a new atomic structure, one that kept the electrons around the atom but introduced the atomic nucleus, the center of mass, with protons and neutrons.
How did that explain the deflection?
Well, a proton is vastly larger than an electron, so it created the center of mass. Thanks to the proton, we now know that individual atoms have a substantial mass.
Wow, that makes it sound like protons are everything and electrons are useless.
You may think that, but it's actually the complete opposite.
How? If atoms are made of the same stuff, why do they act so differently? Why do you get table salt with sodium and chlorine, but with water and rubidium together, you get an explosion?
The answer is small. Tiny, actually, for the electrons determine the chemical properties of atoms, especially how they bond with other atoms around them. Every atom has its own number of electrons, and this decides what an atom can do.
So Thomson discovered what electrons are in atoms, and Rutherford helped explain how?
How electrons are used? Yeah, and that's why Rutherford's gold foil experiment is so important in the history of determining the atomic structure. Oh, there you have it.
Oh, it's interesting, Annabelle. Why are you telling me this? I'm in AP Bio.